Okay, so I'm going to show something kind of cool. And so basically this is um, the STM32F429 board. And what I've done over here is I've downloaded buildroot. So let me go to my directory here. So I have the builder downloaded in this directory here, and then if you look into the configurations, you will find that there is a configuration for execution in place for STM32F429 disco xip def config. So once so the way it works is you just clone the GitHub, which I've already done before, and then you do make, and then do an STM32F429 disco xip def config. I was gonna just save the configurations into the .config file, and then let it finish, and I just do a make. So I've done this before. It's fairly straightforward, just two-step process. And once that's completed, what happens is it's going to output into this folder a few images, and it's going to take a while, but let it finish. This is the folder where so here it actually did what it needs to do, right? There seems to be a problem there, but I guess I have to do a clean and then rebuild it again. But anyways, once it's done, it actually it creates a bunch of files over here. Of the files, the ones that I'm interested in is the STM32 disco.dtb file, the disco.bin file, and the execution xip image. So just because there's so many files that confused, I copied them over here, and then I have a program to download this file in. So this is Linux. It's an virtual machine, and I'm actually going to the Windows program. I did a FileZilla. I connected to that directory, copied the 3 files over here, and then I went to this program called as STM Programmer. Let's pull it up. And I think the reason why the other program the make didn't finish is because I think I had renamed the directories and stuff like that. So anyway, let's look at this one here. So this is the program that actually we can use to program the board. And so I'm just gonna first connect, and the board's already connected, and it actually so the section that I need to go after this is over here. Now I'm going to download all these 3 files one after the other, and the thing about it is this program it has a filter for b.binary and stuff like that. So if you just have a file with no extension, it's not going to show up over here, so you have to rename the files. I rename all of them as bin. Okay, so the first thing I do is to do a full chip erase, because I'm going to be downloading files to different locations. So I'll start with a clean slate first. So mass erase successfully achieved. So then after that, I'm gonna go here and download the first thing, which is this guy here. It doesn't have any more information about it, but it actually is the AF bootloader. So I'm gonna say start programming, and that completed right away. The next file is this DTP, which is the device tree. And then after that, I'm just going to write this to 804,000 and start programming it. That completed as well. And then the last thing is the execution in place. That one goes to 803,000 and then say start programming. This file is close to 2 megabytes, 1.89 megabytes, and so it takes a while. So let it finish. It's gonna complete. Done. So I'm gonna disconnect from here so that the serial port on it is free. And then I'm gonna pull so just device manager. I go to device manager and I say, hey, show me the ports that are connected. So COM5 is the one which is ST Microelectronics virtual COM port number 5, and I have a PuTTY here, and it does show COM5 115,200. And then there's one thing I do is to say the flow control to be none, and so then I open the port. I'm gonna make this screen a little bigger, right? And then I'm gonna power cycle that. So that programming is done. Takes a while, gives you this dot, and then boom, it comes up. That's it. We are in. So we can clearly see that this is the Linux, the latest version 6.1.95 preempt. It's just compiled today. Was it? No, actually a couple of days back. It's for the ARM v7, and over here we can see that it actually detects the CPU version. It says it's the STM32F429 disco board, and let's see, what else can I read from it. Well, the root is in RAM because obviously it executes, but a lot of the commands are loaded to the RAM while it runs, and then they run from there. And this is interesting here. It has a pin control subsystem, and we can see that it actually added a lot of GPIO banks. So I'm gonna try and work with these GPIO banks and then see if I can toggle some LEDs and stuff like that. The UART4 is initialized as well. STM0 is the print K is going to be printed. There's a SPI driver is also in the SPI RTC is started as well. There's a gyro or gyroscope is there inside it, and I think there are a few other things that I didn't include it in the device tree, so I'm going to have to improve that. And it says here this architecture does not have kernel memory protection, so and which is right, because this is a non-MMU. This is an ARM v7, has no MMU, and the total, let's say df-m. Then that doesn't show up. This file system. The whole size of this is we are actually being able to fit it in less than 2 megabytes of space. So this has an internal flash of 2 megabytes. So yeah, if we go to dev directory, and then we can see actually there are these GPIO chips 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I think each has 32 IOs in them, so we should be able to see something with those. And this seems to be that's what they were saying, the TTY STM0 is a serial port. Let's look at the sys, and devices. Oopsie. So there are actually two LEDs, a green and a red LED, and the red is constant red, the green is blinking as if like a heartbeat. And then they are showing the I2C adapter as well. Okay, so one thing I want to show is the fact that how did I get those memory addresses. I got it because I have looked at this file. If you go into the buildroot in board microelectronics, STM microelectronics, and then STM32Disco, let me just show what I'm talking about. So if you have to go into buildroot boards, ST electronics, microelectronics, STM32F429 Disco board, and then open this flash.sh file. I have not worked with the OpenOCD right now. I can try and use it. I like the other program in Windows though, so I think you can use this one too. But over here it says that this guy goes at 800,000, the other one goes at 4,800 C1000, what do you call. So the DTP is just before the kernel and the kernel is after that. And this program actually creates or bundles the rootfs in this XIP image as well. That's how it does it, and somehow I think they CPIO that or into the RAM, and from the RAM it kind of runs. So that's how I got the idea. Then I download those files and then we're good. Yep. So I can do a make clean over here, and then I can try to rebuild this whole thing again. It's gonna take a while to finish. It takes let's do a make clean and then so there are probably a few videos out there which actually talk about F429 being ported to the latest kernel. This is July 2024, and I'm using the 6 point was that 6 kernel, was it uname dash a 6.198. So that's the kernel I use right now. It's still cleaning up here. Let it finish. The thing I like about this, the little guy here is, so make menu config is, I open this, it's starting up. Okay, so let's look at this. So it's ARM, it's a Cortex M4, and this is what you get is a soft load. We are using a ton too because it's a Cortex. We are doing a flat binary model. The tool chain is buildroot and it uses micro clipc. I think that's the only option that shows here. Kernel is this. Oh, custom kernel. I thought, okay, never mind. This is 6.1, just takes up automatically. Over here I didn't have to change much actually, and so this is where this is the part for the execution def config for the buildroot, the entire buildroot actually, the uses. Then we go to the system config. We're using the busy box here. yeah, we get all this. This is regular stuff. I haven't put a password for root. Shell sh is the default shell, and it says run a gitty, which is a login prompt. Remount root file system, read write during boot. So once it boots up, it's going to rewrite. The file system is read write, and these are the paths. This is the standard paths that we want. Okay, now this is interesting. This is the part. This is the file which is going to be run. Let's go here. Buildroot board, ST microelectronics over here, and STM common, and 4xx, and this is the post build. Let's look at this file and see what it says here. Oh, this is just adding the host name. Okay, so I guess we are saying we don't want any host name, and dv pits is not to be supported as well. Okay, so this is a script that runs after. Oh, that runs before you run the before you start building. So this is the kernel. Let's look at the kernel. We got the kernel. Yeah, and this is the config for the kernel. It's an execution in place. Has a device tree blob, and this is the name of the device tree blob. I did not change this. This is standard, and is there target packages. There's a lot of target packages. I don't know. CPU is the root file system, and it is now RAM file system is linked into the kernel, which is what I was talking about. Now this is where the AF boot for STM32 is. It is to be loaded on 800,000, and this is the device tree which we were talking about. 804,000 is the device tree loading address. This is the kernel address. What else? Let's see. This is, oh yeah, so we do build OpenSOCD in this one. I probably will have to try that again and see how to, that's pretty much it. And once we do that, start building again, it's gonna start the whole process. So yep, so that gets the whole thing done. Thank you.